Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I have taken a problem in Lagrange's equation. I have already done a problem in Lagrange's equation. In order to make the students understand better and approach two problems, I have taken this problem, which is also very important from the point of the university examination. There is every possibility that you will get this problem in your university question. So understand well, and if you have any difficulty, you may write in. You can give your comments. I will look into that and see that I can do my best to you. Okay. So with this small view about me, let me come to this problem. Now, this is the problem that is given, and we have to find the solution to the problem. Normally, if a partial differential equation is given, by solution I mean finding Z. Finding Z is called the solution to the problem. But this is a Lagrange's equation, and for this Lagrange's equation, which is normally of the form, see, Lagrange's equation will be of the form like this. It will be like this: PP plus QQ is equal to R. So this is the form of a Lagrange's equation, where this P is dou Z by dou X and Q is dou Z by dou Y. And P, Q, R are all functions of X, Y, Z. See, from this itself we can understand. So this P is dou Z by dou X, Q is dou Z by dou Y. This is your capital P, which is a function of X, Y, Z. This is Q, which is again a function of X, Y, Z. This is R, which is again a function of X, Y, Z. And this is the problem, which is rewritten in this form. Now identify this as P, this as Q, and this is R. As in when you are given a problem in Lagrange's equation, you have to identify it. First, identify the problem as a Lagrange's equation. Once you identify, immediately you can write the subsidiary equation. What is that subsidiary equation? The subsidiary equation is given by dx by capital P is equal to dy by capital Q is equal to dz by capital R. And as I told you, your solution must be of the form f of ub is equal to 0, where this u is a function of x, y, z, b is a function of x, y, z, this a and b are constants. So this is your solution. So this is what I should find. This is what I should find for the problem. So what I do here is, once this is given, I write this subsidiary equation. Here, once you write the subsidiary equation, means now our job is to find the two functions u and v. The two functions u and v can be obtained using two methods. One is called the grouping method. I have written here grouping method. This is a multiplier method. This is multiplier method. Multiplier. Multiply. See, it's a method of what we do is, first I explain this. So this is using multiplier method, and this is called the grouping method. What is the meaning of grouping method? You are having this, see, this is a by b is equal to c by d is equal to e by f, something of that form. It is the ratios are equal to one another. Now we will use the properties of ratio and proportion, like component or dividend or something like that. Okay, in order to get the solution. Now here you see that I am going to group it. Group it means you can take either these two or these two or these two. You can group them. Group them and then find the function. What I do here is I take these two I group these two. That is dy by x into y plus the xy plus zx is equal to dz by xy minus zx. You find that this x is common, so this is x into y plus z, this is x into y minus z. So x will get cancelled, leaving you with dy by y plus z is equal to dz by y minus z. Do the cross multiplication, you will get y dy minus z dy is equal to y dz plus z dz. And from this, what I do is y dy, bring this z dz to the left hand side and take this z dy to the right hand side. Now you will find that this is z dy plus y dz. Now the problem of finding this u and v solely depends on the knowledge of integration. We have to integrate and get the values. Okay. Now you see that this, so you must bring it to your form where you can integrate. You see that this y dy can be integrated, z dz can be integrated. Coming to the right hand side, z dy plus y dz. Once you see this, you must be able to identify it in such a form. You must be able to identify, because that comes through a lot of practice and understanding of the subject. So this is z dy plus y dz. So this is nothing but d of yz, because if you take the differentials, it is y into dz plus z into dy. Taking the product, using the product rule, you will get y into dz plus z into dy. So if you take the differential, you get this. So instead of writing this z dy plus y dz, I write it as d of yz. Now you see that I can integrate on the left hand side. Integral of y dy minus integral of z dz, integral of yz. And you must know that integral of dx is equal to x. You know very well this integral. So this integral of d of yz will be nothing but yz plus the constant you must write, because this is it is not a definite integral. Okay. Now you see that you get y squared by 2 minus z squared by 2 is equal to yz plus a constant. You do the cross multiplication, y squared minus z squared is equal to 2yz plus you will get 2c. 2c is another constant, you can put it as e. So what is that you will get here now? So bring this to the left hand side, y squared minus 2yz minus z squared is equal to a. Now this is what now you identify this as your one of the functions u, namely y squared minus 2yz minus z squared, and u is equal to a constant. Now this forms the first solution, that is a part of the solution. U is a part of the solution. So u is equal to so much, a is the one part of the solution I have got here. That's why I told you, u is equal to a. So I have got this u is equal to a for this problem. Now here what is that I have done here? I have grouped, I have convened, because I know that when I say this I am able to understand that I will be able to get one of the functions. Okay. Now, so I have used this and I have cross multiplied and I have used small knowledge of integration to get the function u. So this part is over. Now we have to get hold of the other function v. How to get that v? Here I have used this multiplier method in the sense that dx by the denominator is equal to dy by denominator is equal to dz by denominator. All these things are equal to, I am using the property of ratio and proportion. X into dx, y into dy plus z into dz. Once you multiply this numerator by x, means the denominator must also be multiplied by x. You multiply this by y, therefore you multiply the denominator also by y. You multiply this by z, multiply this also by z. So what is that you will get here? X dx plus y dy plus z dz divided by x into z squared minus 2yz minus y squared plus y into xy plus zx plus z into xy. Now if you go for the simplification here, you will get it as xz squared minus 2xyz minus xy squared plus y squared plus xyz plus x y z minus z x square. So you see that x is z square and x is z square. Value you can see here. You will get it as here z squared x. See z squared x squared z squared. See z squared x and z squared x will get cancelled. Minus xy squared plus x squared xy squared xy plus xyz plus xy 2xyz minus 2xyz. So all this will get cancelled easy. So that is why you get this value to be 0. Now what do you see here? Dx by denominator is equal to dy by denominator plus dz by denominator is equal to x dx plus y dy plus z divided by 0. 0 into anything will be 0. Can you understand? So what I do here is that here one more step that you can write. What is that you write here? X dx plus y dy plus z dz is equal to 0. So this forms, I have skipped one step here. So that is x dx plus y dy plus z dz equal to 0. Now you take integration on both sides. While you go for an integration, try to understand that it is x dx. If you don't have it in this form, that is the variable, and the variable has to be integrated with respect to the same one. Only then you will be able to do this. So we are able to get it as x dx plus y dy plus z dz is equal to 0. You go for the integration, take integration on both sides, you will get integral of x dx plus the integral of y dy plus integral of z dz is equal to some constant. Because integration of 0 is after a constant, integration of a constant, integration of the of 0 is a constant. Because differentiation of 0 will be, differentiation of a constant is 0. And integration and differentiation of reverse process of each other. Okay, that is why you get this to be what? If you differentiate this, if you integrate it, if you differentiate this, you get 0. If you integrate it, you will get the constant c. So you are getting it as the constant c dash. Now again, that is x squared by 2 plus y squared by 2 plus z squared by 2 is equal to c dash. Go for cross multiplication. You get it as x squared plus y squared plus z squared is equal to 2c dash. You call it as another constant b. So what do we get here? It is just like of the form v is equal to b, where v is nothing but your x squared plus y squared plus z squared. Therefore, we are able to get another function v, which is nothing but x squared plus y squared plus z squared, which is also equal to another constant b. Now we are able to get two functions. What are the two functions? I got here one function and I got here another function b. Now the solution is nothing but what? Therefore the solution to the problem is, so you have got this. So you have got this, we have got here. Therefore the solution to the problem is given by, so what is the solution now? Therefore solution to 1. Therefore solution to the problem is say what is the solution to the problem now? It is f of, what is your u? U is y square minus 2yz minus z square. Y square minus 2yz minus z square. Another function is x square plus y square z square is equal to 0. See, I have written here, this is the answer. I have written here f of uv, this is f of u. So this is the solution, and you must know that a partial differential equation need not have a unique solution. It need not have. The solution can be different also. So here if you from this you can get this problem. That is, from the solution, if you are given the solution, you can coin the differential equation.